Okay, in this video, we're going to learn how to solve rational equations. So what's a rational equation? Well, it's an equation, so it has an equal sign in it, and it contains rational expressions. And a rational expression, remember, is a polynomial over a polynomial, so it's a quotient. It has variables in the numerator and denominator, but it doesn't have any radicals or anything like that. So I'm going to first just list all the steps, and then I'm going to go through a couple of examples. So the first step for solving any rational equation is to first write down all the excluded values. What are excluded values? Well, those are the values of the variable, the numbers that you could plug in for the variable that might make any of the denominators 0. Remember, we can't have a 0 in the denominator of a fraction. Then the second step would be to get rid of all the fractions. And this is something that might be new for some of you, but in Alex has been showing you how to do that. I think I've done it in a couple videos with other types of fractions, but it's really, really important for rational equations to use this method because it really, really simplifies your life. So how do we do it? We get rid of the fractions by multiplying the entire equation, or both sides, by the least common denominator. So some of you are used to using the least common denominator only to rewrite fractions so that they all have the same denominator. That's how you've been using it in the past. And that's not wrong if you do it. If you do that with rational equations, it's not incorrect and you won't be marked wrong. But I think you'll decrease your chances of making mistakes if you use this method. If you, instead of combining fractions and rewriting them with a common denominator, instead you just get rid of the fractions by multiplying by the least common denominator. So in the next two examples, I'll show you how that works. Then the third step, you've gotten rid of the denominators, so you now have an equation with no denominators, and you can start combining like terms until you get either a linear equation, which we know how to solve, or a quadratic equation, which we also know how to solve. And then you solve. So you solve using appropriate legal methods. But you're not quite done. Once you get a solution, remember you've just solved a linear equation or a quadratic equation, but your goal was to find all the solutions to the rational equation. So you have to check to make sure that one of your answers isn't an excluded value, and we have to throw it out. And we call those extraneous solutions. So you throw out any extraneous solutions that aren't really solutions. And those are usually going to be one of the, or two of the excluded values, or more. So just check your answers against your excluded values that you found at the beginning. All right, let's start with our first equation. It says solve for W. And notice we have three rational expressions, and one of them, the one on the left, has a quadratic in the denominator that's not factored. The other two fractions have a binomial. Each one has a binomial, and they're in completely factored form. So the first thing we need to do before we can find all our excluded values or the least common denominator is we have to factor that quadratic. And that thing factors as v minus 5 times v minus 2. And then I'll just rewrite the right side. And now we can tell by looking at it what our excluded values are going to be. The excluded values are just going to be the numbers 5 and 2. Those are the only two numbers that would make any of the denominators 0. And we can also tell by looking at it what the LCD is. The LCD is going to be the product, v minus 5 times v minus 2. Okay, so let's take that LCD, and we're not going to rewrite the fractions using the LCD. We're not going to rewrite everything so it has the same denominator. What we're going to do is just multiply the left side by that LCD and the right side by the LCD. So we're multiplying. Remember, we have to multiply. Whatever we do on the left, we have to do on the right. And now here is where I'm going to give you a warning. We want to cancel, but we're not going to cancel yet. Some of you are going to try to cancel right away on the right-hand side. Notice we have a sum, 1 over v minus 5 plus 3 over v minus 2. So in each of those terms, something different will cancel. We can't cancel yet on the right side. So what I want you to do is use the distributive property. We have to distribute. So it's the first term times the LCD plus the second term times the LCD. That's the distributive property. We have to do that first before we can cancel. And now, let's before we start canceling over on the right, let's look at the left side. The left side didn't have a sum. We have the LCD, v minus 5 times v minus 2 times a rational expression, 7 over v minus 5 times v minus 2. So we don't have a sum. We don't need the distributive property. We can cancel right away. Notice that there's a v minus 5 in the bottom and the top, so those cancel. And there's a v minus 2 in the bottom and the top, so those cancel. And so the left side, we're just left with a 7. We got rid of the entire fraction on the left side. So on the right side, we now can start canceling. After we use the distributive property, we have two terms that are each products. So the first term is the product 1 over v minus 5 times v minus 5 times v minus 2. So that clearly has a v minus 5 in the top and the bottom that cancel. The second term is 3 over v minus 2 times v minus 5 times v minus 2. So something different cancels there. So the v minus 2's go away there. So now let's rewrite the equation. We get 7 equals v minus 2 plus 3 times v minus 5. So we got rid of all of the denominators just by multiplying everything by the LCD. We didn't have to rewrite any fractions with new denominators. So this is something that might be new for a lot of you, and I want you to try to practice doing it this way. I think you'll find that it's simpler and you make fewer mistakes. So now, what kind of an equation does that look like? Well, we don't have any exponent. Well, the exponent is 1, so that means it's a linear equation. And remember that all we do with linear equations is we isolate the variable, get the variable all by itself on one side, and we get a number on the other side, and that will be our solution. So let's do it. On the right side, let's distribute 3 times v minus 3 times 5. Combine the v's, we get 4v. Combine the numbers, we get minus 17. So now it looks like we can add 17 to both sides. We get 24 is equal to 4v. And we just divide by 4. And we get 6 equals v. And now before we circle that answer, we compare it to the excluded values. We look at the top. The excluded values were just 5 and 2. And since we got 6, we can circle that as our answer. And we can go back later and plug that back into the rational equation to make sure we really didn't make any mistakes. But we didn't have any extraneous solutions to throw out. Okay, so let's look at the next example. This one says solve for w, and we have negative 9w over w squared minus w minus 20 minus 2 over w minus 5 equals w over w plus 4. So we can't write down excluded values until we make sure every denominator is factored. So we do have a quadratic in one of our denominators, and it looks like we can factor that. It looks like that will factor as w minus 5 times w plus 4. And then I can just rewrite the rest of the equation. And now looking at this, we can see what are the excluded values. Well, 5 would make it one of or two of our denominators 0, and also a negative 4 would make a couple of our denominators 0. So we have to write those down at the beginning so we can check at the end. Make sure that none of our solutions are one of those numbers. So now what's the least common denominator? The LCD is going to be just the product, w minus 5 times w plus 4. So now remember what we're going to do with the LCD. We're not going to rewrite the fractions using common denominators. What we're going to do is multiply both sides by that product, w minus 5 times w plus 4. So let's write that out. Okay, so look at both sides. Our goal is to cancel denominators so they all go away. But look at the left side. The left side we cannot cancel yet. So this is a point where some people try to cancel too soon. We have a difference on the left side, so we have to use the distributive property. So we write the first term times that w minus 5 times w plus 4, and then minus the same thing, we multiply the second term by w minus 5 times w plus 4. So the second term was 2 over w minus 5. And now, before we write down the right side, we notice that the right side didn't have a difference. It was just the product w over w plus 4 times w minus 5 times w plus 4. So we can cancel right away on the right side. So the denominator w plus 4 cancels with the w plus 4. So we're just left with a w times w minus 5. Okay, so now let's look at the left side here. We look at the first term. We have a w minus 5 times w plus 4 times negative 9w over w minus 5 times w plus 4. So both the w minus 5's cancel and the w plus 4's cancel. So everything canceled in the first term. But in the second term, only one thing will cancel. The w minus 5 in the denominator will cancel with that w minus 5 in the LCD. So you always have to use that distributive property first before you start canceling when there's a sum or a difference, so that you're careful enough you don't cancel the same thing in each term. So now what we're left with on the left side is just the negative 9w minus the w plus 4 times the 2. On the right side, if I distribute, I get w squared minus 5w. So now we got rid of all the denominators. We no longer have a rational equation. We have what looks like to me as a quadratic, because we have a w squared over there on the right. So that's a quadratic equation. And we have several methods of solving quadratic equations, but the most important thing is that the very first step is to get everything on one side so that you have a 0 on the other side. Okay, so that when you have a quadratic equation, make sure you get everything over on one side so you get a 0 on the other before you start solving. All right, so let's distribute the 2 on the left, so we get negative 9w minus 2w minus 8. And combine the w's, we get negative 11w minus 8. And now I'm going to get everything over on the right, so add 11w to both sides, add an 8 to both sides, and I get 0 equals w squared plus 6w plus 8. All right, so now I'm going to turn the page, rewrite the equation. So it looks like I can factor the right side. The right side factors as w plus 2 times w plus 4. Now, I noticed a lot of you don't check your factorizations. You just try one thing and then you move on. So always, always, always check to make sure you didn't make a mistake when you factored. So all you have to do is FOIL it back together. So if you FOIL, you'll get w squared plus 4w plus 2w plus 8. 4w plus 2w is 6w, so it works. A lot of you are making mistakes in your factoring that you could easily catch and fix. It will take you 2 seconds. So please, please, please check your factorizations. All right, so now we have a product of two things equaling 0. That means that one of the two factors had to be 0 to begin with. So we write w plus 2 is 0 or w plus 4 is 0. And that's called the zero product property. When you have a product of two real numbers equaling 0, that means one of the numbers had to be 0 to begin with. So now we solve these separately. So the first one gives us w equals -2. The second one gives us w equals -4. And before we circle both numbers, we go back and check our excluded values. And it turns out one of our excluded values was -4, so we have to throw that out. That turned out to be an extraneous solution. So our only solution is w equals -2. And that's it. So remember the steps. And remember how to use the LCD. The LCD is used to cancel out all of the denominators. So you change your rational equation to either a linear or a quadratic. Okay, happy solving.